Hi guys, welcome back to my channel. So it's me Dheeraj here. So in the previous video, I have tried to cover the basic core AWS services. Like I have explained the compute services, the storage services, networking services, and database services. So if you haven't watched it, please go and watch it. And today, I'm basically trying to cover the rest of the services whichever be there. Like today, I will explain the security, anti and compliance services, management and governance services, billings and cost management services. Then after container and orchestration, Kubernetes services, developer tool services as well. And at last, I'm going to explain the migration services. Fine. So in this video, I will try to cover all those REST services whichever we left in the previous video. So without wasting time, let me have to proceed to my GitHub repo here. So if you haven't followed my GitHub repo, please feel free to follow it because I've beautifully documented these like every if you're aspiring for cloud practitioner exam or solution architect exam, I think I've beautifully documented each and every concept in this repo. So if you haven't followed it, please feel free to follow it because it's really like useful. So without wasting too much time, let's go to this. Yeah. Now, one concept like in the last videos also, I have told you one concept like AWS, well, like security is basically a AWS shared responsibility model. Fine. It means the infrastructure related things, AWS is basically be responsible for all those infrastructure related things. Like they have been responsible for taking care of the hardware, they have been responsible for taking care of the network, they have been responsible for taking care of the hypervisor. Fine. But we as a customer are basically responsible for the data which is inside that cloud. Like we are basically configuring the IAMs, we are basically encrypting those data, we are basically enforcing the firewalls, and if possible, then we are trying to patch those uh, servers as well. Fine. So that's why it's mentioned like security is basically a shared responsibility model in AWS. Fine. These things you have to keep in your mind because while preparing for those exams like cloud practitioner solution architect, this concept is very useful. Now moving forward, the first services is IAM. Fine. IAM it means identity and access management. Fine. So it basically controls like who can do what in your AWS account. So it basically like there is a concept like authorization and authentication. I think you are quite familiar with these two terms here. Authorization, it means are you a valid user? Authorization, it means what sort of permissions you are having. Fine. So whenever you are valid users, which services you are permission to use. Fine. So these two concepts are basically comes inside this IAMs. So what it does, what it provides, it basically provides the IAMs users, group and roles. I think you are quite familiar with these three terms, users, group and roles. Roles, it means whenever once AWS services is trying to connect the other AWS services, in that case, we are basically giving the temporary access. Fine. For that, we are basically using the IAMs role. Fine. So this IAM basically provide a fine-grained policies and it's basically a JSON document. Fine. And it basically like whenever we are creating a users and if you are one more thing is there like whenever we are using the AWS account from the AWS best practices we should have to avoid using the root account on a regular basis. Fine. We have to import the MFA and we have to create an IAM user and have to use it for other purpose. It just like I have told you from the best perspective point of view, but it's fine. Like if you're using root account as well, it's fine. But you have to avoid using the root account for your daily purpose. You have to create IAM users and have to use it. So in this, like it basically that's why this I've already mentioned. Like this role is basically temporary credentials. With the help of this, you can create a temporary credentials and attach it to a particular services. Examples are mentioned here like your DevOps team deploys to EC2 using a GitHub Actions. You don't want to store AWS keys in repository. So you can create a IAMS role. Like you just have to create a GitHub deploy role and have to attach it to EC2 instance. It means your GitHub has access to like GitHub has permissions to access the your EC2 has permission to access the GitHub account. Fine. That's why you have to enforce these two policies here, like EC2 start instance and EC2 stop instance. It means they would be able to only start and stop the instance. Apart from this, they can't able to do any other operation. Fine. That's why this role is basically be used for temporary credentials. Fine. It's not a permanent. With a couple like with a passage of time, it get expired. Fine. So that's all about the IAM services. The second service is basically AWS KMS services. KMS is nothing but key management services. So it is just used to create and manage the encryption key. Like whenever we are dealing with the encryption key, we have to use this KMS here. Fine. Like let us suppose if you want to store, like if some customer has stored something inside a S3 bucket, then whenever we are uploading the object in the S3 bucket, AWS has like features like server side encryption is there. Like whenever we are uploading any object, by default server side encryption has enabled and your data will get protected. Fine. So like whenever any user is trying to fetch or use their data, they should have to use that particular keys. If they don't have key, then the data is unreadable, like they couldn't be able to read it. Fine. So that's how this KMS is working. That's why it basically be useful for encrypting S3 data. You can apply it on EBS volume as well for encryptions. We can apply it on RDS or DynamoDB. It is used in secret manager as well. So these all are basically the things are there where we can use it. So that's all about the AWS KMS services. The third one is there, AWS WAF. What is WAF? WAF is nothing but a web application firewall. So it just protect our, oh, one second. What it does, so it basically protect our application at layer 7, like HTTP or HTTPS layer. What it does, so it basically try to block some threats like SQL injections, cross-site replication, bot attack, bad IPs, and rate repeating. Rate repeating is there. It means whenever a large number of IP addresses is going to stack your servers, in that case, you can limit the rate. It means you can enforce rules like only that particular amount of IP addresses will reach my servers. So likewise, you can limit your number of requests to your particular servers as well. So from where this AWS WAF can be attached, so it can be attached on the cloud front, it can be attached on AWS, it means application load balancer, it can be attached on API gateway. Fine. So these are the basic services are there where we can use it. Examples are mentioned like, here, like let us suppose if your EKS application faces a bot traffic. Fine. In that case, what you have to do, you have to first to enable the WAF and have to enable like we have to enable the bot controls rule as well in that. And after that, you can enforce rate limiting rules like only 100 requests per minute per IP. It means from a particular IP, if the number of requests exceeds that limit, then that particular IP addresses is going to be blocked. Fine. So that's how you can protect your application from the threat. Fine. So it's a very important, like if you are in cloud or DevOps domain, these services are being frequently used by the developers. Fine. So this is very important services, AWS WAF, and a lot of questions has been asked, especially in this solution architect examination from this. Fine. This is very important. You have to get remembered, like you have to whenever WAF is the whenever questions has been asked from this WAF, you just have to remember like they must be talking about the application firewall, web application firewall. Fine. Okay. Fourth one is AWS Shield. AWS Shield, it means it basically protect against the DDoS attacks. What is DDoS attack? DDoS is nothing, just a distributed denial of services attack. Fine. It means whenever number of requests increases, it basically going to breach the data is basically going to damage our servers or some other backend services. Fine. So that this AWS Shield has basically two versions. The first one is AWS Seal Standard, which is free, and it basically automatic DDoS protection is there. We can use it with CloudFront, Cloud53, and ALB. But in case of advanced, like Sealed Advanced, it basically provided 24 by 7 DDoS response time, cost protection, WAF integration, and real-time attack visibility. This is very important. Like I've been involved, like the one questions has been asked, like which is one scenario based questions will be asked. So one thing that you have to remember, like whenever they are talking about the DDoS protection and real-time data visibility, the only one thing that is going to be stuck in your mind is basically sealed advance. Fine. Advance, it means real time. If they wouldn't mention some real time here, it means you can proceed with the standard. Fine. So that's basically the difference between these two, standard and advanced. Examples are there. Like let us suppose if your application site is there, which is behind CloudFront, gets a 10 million requests per second. Fine. It means DDoS attack. What you can do? Either you can configure the sealed standard. It just absorb most of the IP address and it can protect your application. Fine. Otherwise, you can enforce the sealed advance. What it does, it basically block the pattern based on like whatever the IP addresses are there. It basically firstly analyze the pattern and it just block all those pattern. That's why you can use AWS sealed advance as well. This is basically advanced version of a standard. So, but it is a bit costly here. So if the number of requests are coming like less, you can go with sealed standard, but if they are more, you have to enforce the sealed advance here. So this is all about the AWS seal. Fifth one is the AWS Mackie. What it is basically used for sensitive data recovery. Fine. What it does, it basically automatically find the sensitive data such as the emails, names, or Aadhaar cards, uh, credit cards numbers, or secret inside a file. How it's working? Like let us suppose if your S3 bucket contains a logs uploaded by the user, fine, and you just run a Mikey. What it finds? It basically finds the password which is stored inside that logs, or emails or phone numbers are there, or any encrypted data. It means this MAC is basically be in roughly it basically works on the ML models or machine learning model. It basically you can simply say fetch the sensitive information from a particular log file or some like whatever the data we are feeding. Fine. So that's why MAC is used for sensitive data discovery here. The next services is their AWS Guard Duty. Fine. What it does, so it is used for threat detection, and it is also a machine learning based threat detection services is there. So it basically be used to detect the malicious IP communications, crypto mining malwares, unusual IAM activities, suspicious S3 access. Like is there anyone who is suspiciously trying to access the S3 bucket? Fine. EC2 compromise behaviors. Fine. Like their example is there. Let us suppose like EC2 instance communicating with a known crypto mining IP address. Fine. What you have to do, you just investigate and find that an engineer exposes the SSS port 22 publicly and the server was compromised. Fine. In that case, what you have to do, you have to rotate the keys here. You have to patch the EC2 instance if possible, and you have to, with the help of this, you can restrict the security groups because yet security group like port 22 is publicly open. So you have to allow only those particular port only which is useful. Fine. So with the help of this, you can enforce the security inside like your for your application. Fine. So this AWS guard duty is basically be used for threat detection here. Fine. These are basically the SP like threats. Moving forward, the seven services is there. AWS Inspector. What is AWS Inspector? So AWS Inspector is basically be used for vulnerability scanner. Like it basically scan the EC2 instance. It basically scan the container images. It basically scan the Lambda function. How it's working? Like whenever we are pushing the Docker image, let us suppose if you're from DevOps, then I think you're quite familiar with the Docker and Kubernetes here. And ECR is nothing, just a Docker repository is there where we are basically storing the Docker images. So whenever we are pushing the Docker images to ECR, and if you have integrated the inspector here, AWS inspector, what it does, it basically scans our images and check whether is there any critical vulnerability exposes is there or not. If yes, then they will get a notification like there is something in your particular images. Fine. What you have to do, either you have to update your base images or you have to upload it again so that you can enforce security. Fine. So that's how this AWS inspector is being used, and it's basically used for vulnerability scanner. It's just a scanner. Fine. It scan your whole code, or you may simply say like your images. Fine. Next, AWS Cognito service is there. It's basically we use for user authentication for application. Previously, AWS Cognito is basically AWS services that provide user sign-in and access control for the web and mobile application, include the authentication, authorization, and user management securely at a scale. It means whenever we have to manage the users at a scale, we are basically going to use this AWS Cognito services here. Fine. For a particular user, like for a particular application, if you have to manage that users. So it has two components, like one is user pool is there and another is identity pool is there. User pool, it means a user directory for single sign-in. Identity pool, it means it is used for granting a temporary AWS credential. Fine. That's why it has features like it will support the like social login, like whenever we have to log in to this Google's or Facebook or any other social logins, we can use JWT token is there. These things you can use with this. These are basically the features of this AWS Cognito. The next one is there, Cloud SHM. What is Cloud SHM? Cloud SHM is basically used for hardware security model is there. Fine. It's a dedicated and single tenant SHM is there, which is used for cryptographic operation. Fine. Single tenant, it means for like let us suppose for each application there is a different there is a different database is there. Fine. Multi-tenant, it means one application is going to be shared with a lot of database as well, like this you can correlate. So AWS Cloud SHM is basically a managed services which is providing a dedicated hardware security models in the cloud for securing and for securely generating, storing and managing cryptographic keys. It means whenever you have to generate, store and manage the cryptographic keys, which is helping like FFPS 143 with a single tenant access, full control and complementing services like AWS KMS for application. Like whenever we have to manage, store or generate the cryptographic keys, especially in case of hardware, like hardware security model, we are basically using this cloud SSM there. Fine. What are the use cases of this? Like it is used for protecting the SSL or TLS keys for web applications. It is used for encrypting databases like for RDS, for Redshift. It is used for digital certificates. So you can go through it. These are the subjective like theory. Are there some which is there? Examples are there like let us suppose a bank needs these questions like questions have been asked from this portion like in banking this compliant keys are basically be used for storage. Fine. Let us suppose bank needs PCI DSS compliant key storage. In that case, they have basically deployed the Cloud SSM cluster and they just used to encrypt the credit card related data using this algorithm. So most of the bank basically using this clusters to just encrypt those datas like customer datas. Fine. That's why it's basically used in banking sectors as well, Cloud SSM. And one difference is there, like how KMS is different from Cloud SSM. So KMS is basically managed in multi-tenants, fine, and it was simple. But in case of Cloud SSM, it's a dedicated and it's a single tenant. That's why we are having the full control over it. Fine. So these two are basically the difference between the KMS and Cloud SSM. The next services is there AWS Firewall Manager. Fine. This Firewall Manager is basically be used for central policy management. Like whenever we have to like manage the security policies across multiple AWS account like AWS organizations. AWS organization is there through which we can we can manage the multiple AWS account. So in that case, like whenever we have to manage those policies at a center level, we can use this AWS Firewall Manager. How it's working, like there is examples I mentioned there. Like let us suppose if your company has 60 AWS account, like dev, QA, prod, analytics, and client, what you do, you want like let us suppose you want a no security group should allow this 000/0 SSH port. Fine. So by using this firewall manager, you can create a security policy, apply it to organization's root, and it will automatically enable. Fine. And you have to enable this as well. So what it does, like whenever any account is going to like trying to add that this, whenever they are trying to open the SSH, it automatically going to be removed. Fine. That's why it can be used at AWS organization level. With the help of this or at this levels, you can manage the multiple account centrally. Fine. So these are basically the services are there from security, anti, and compliance. So these are like it's a architecture view. Like all those services are there for anti and security. We are using IAMs and Cognito. For data security, we are using KMS, CloudHSM, Mackie. For network security, we are using WAP, Shield, and Firewall Manager. For threat detections, we are using Guard Duty. For vulnerabilities, we are using Spectre here. So just go through it. So this is about the security, identity, and compliance services. So now we have to move to this next sections here, which is management and governance services. Fine. One second. Just give me 1 minute. Yeah, so this is the AWS management services. So AWS management services basically help the organization monitor, control, and optimize the AWS environment. Like management, it means whenever we have to manage the AWS complete services, we are basically using this below services. Out of which this AWS CloudWatch is very important. I will tell you this is very important and this is widely used. Like if you're spending approx 9 hours, like if you're doing 9 hours per day, I think you are quite using this service at least 2 to 3 hours per day. Fine. Because it can be integrated with all those AWS basic services, or you may simply say all services. That's why it's been used for real-time monitoring here in AWS. Fine. And this is very important, AWS CloudWatch. I will show you at my, this is my AWS account is there. I will show you how we can configure it. CloudWatch. It's taking time here. So this AWS CloudWatch is basically a primary monitoring and observability services. It means it can be used for monitoring as well as for observing purpose. Fine. Here it has come. This is basically a dashboard here. Fine. Like if you have to get the log of a particular services, you can go to this log inside as well. Then after matrices are there, network setup, there so many options are there. You can refer to this one. So what it does, it basically tries to collect the metrics, logs, and event from the AWS resources and application and help you to understand the performance and detect operational issues. So whenever we have to do monitoring, or whenever we have to do like we have to check whether we are whether a particular applications are using a high CPU or not, whether they are using like at which uh, everything related to that monitoring, like it basically used for monitoring CPU, memory, disk usage, latency, these all things. And apart from this, it is basically also used to create an alarm to trigger a notification or automated action. It means whenever we can enforce like if the CPU percentage will exceed this limit, then we are going to like stop, or we are going to, you may simply say, increase the number of EC2 instance. Fine. Like if we are configuring the alarm, like if the CPU percentage is going to exceed the 80%, fine, it basically trigger alarm. and we can integrate with other services as well. Like if we are integrating with it auto scaling, it's going to increase the number of EC2 instance as well. So that's why this cloud watch is very important from the monitoring point of view, and it is useful for visualization of data as well. That's why it's a unified and database like this. And there's a log group there. It means with the help of this thing, you can fetch the data there. And it is basically we use for automatically react using the AWS Cloud events and rule. Examples are there like if you have a EC2 instance running on a web application, CloudWatch basically tracks CPU utilization and network input and output. Fine. It means whenever you set an alarm, like if CPU exceeds 80% for 5 minutes, auto scaling is basically going to add another EC2 instance and send a SNS alerts to admin. SNS is again a services that I will try to cover it in application integration services, simple notification service. So what it does, like whenever the CPU utilization exceeds the 80% for 5 minutes, firstly it's going to increase the number of instance. After that, or in parallelly, it's going to send a simple notification services as well, like notification as well via this SNS. Fine. So that's how this AWS CloudWatch is basically being used. The second service is there AWS CloudFormation. Fine. So it's a infrastructure as a code is there. I think if you're from a DevOps domain, you are quite familiar with the term Terraform. Fine. For what purpose we are using Terraform? It means whenever we have to write a code, infrastructure as a code, it means we are going to create an infrastructure with code. It means if you want to create a EC2 instance, S3 buckets, or RDS databases, what we are doing, we have to go to console and we have to create those EC2 instance. Fine. But if you want to create those EC2 instance with a code, we have to write a particular code here. Fine. That's why in Terraform, we are going to create a particular code for EC2 instance. And after that, it's going to create those resources on the behalf of me. Fine. That's how this Terraform in AWS, it's a infrastructure as a code, like it's a cloud formation. Fine. The same Terraform, Terraform, AWS has cloud formation. Fine. What it does, it basically be used. That's why it's mentioned. Just go through the definition here. AWS Cloud Formation is a deployment and configuration management services. In place of configuration management, it's always better to use infrastructure management services that allow you to define, provision, and manage AWS resources using code. And it's written in YAML or JSON template. It basically ensures infrastructure consistency, auditings, and version control deployment essential for monitoring and compliance. Let us suppose if you have write a code and mention the version something like version 1.1, right? And after a couple of minutes later, if you want to deploy a version 1.2, you just have to update your code here. But manually, you have to do a lot of stuff here, and manually, it's a error prone as well. Fine. That's why that's why from a best practice from the automation point of view, we should always have to use this cloud formation here. This is very important in DevOps tool. Fine. And some key features are there with this cloud formation. It basically defines infrastructure as a code using templates. It automatically provision and manage the resources in a repetitive way. It can be integrated with AWS config CloudTrails that I will discuss what is config and what is CloudTrails. It can support a stack policy. All these things are there. These are basically the features of this. Fine. Examples are there. Let us suppose if you deploy VPC, EC2, and RDS instances using a CloudFormation templates, CloudFormation basically keep track a stack record of all those resources. So if someone modify an EC2 manually, dip detection basically flag it. Fine. This basically ensure your infrastructure remain consistent and auditable. That's what the benefit of CloudFormation is like this. Like whenever we have created infrastructure, if someone is trying to or especially like they are trying to modify it, you will get a diff detection here. Fine. The next service is the AWS CloudTrail. This is basically used for auditing purpose. Fine. So this CloudTrail basically records all API call made to your AWS account, like who did what, when, and from where, and which resources were affected. Everything is there. That's why it's regarding to API calls. Fine. CloudTrails, it means they are talking about the API calls. These things you have to keep in your mind. Fine. That's why it basically provides a governance, compliance, and security auditing. What are the features of this AWS CloudTrail? It basically tracks the console, CLI, SDKs, and API calls. It basically delivers log to S3 bucket. If you are configure this API, CloudTrails with the S3 bucket, it's basically try to deliver those logs to S3 bucket. Fine. And it can be integrated with CloudWatch as well for real-time alerts. Examples are mentioned here, like let us suppose if an IAM's user accidentally deleted an S3 bucket, CloudTrail shows like delete bucket actions performed by this user. Like if DevOps admin is there, and it will show the IP addresses as well. At what time he has deleted. Everything are there. Fine. And it is that's why it's basically we help for root cause analysis or security auditing. Fine. For services is the AWS config. It means whenever we have to deal with the resource configuration tracking, we are basically using config. Config, it means they are talking about the configurations. Fine. AWS config tracks configuration changes of AWS services and basically and checks whether they are compliant with the organizational policy or not. How, like examples are there, like you set a config rule like S3 bucket must be public. If someone tries to make a bucket public, AWS config mark it as a non-compliant and can automatically remove public access and notify via the SNS. Fine. So it basically checks in regards to their organizational policies, like whether they are compliant or not. If they are not compliant, it means they can trigger a notification and they will automatically mark it as a non-compliant. Fine. And features are there like it can track configuration history of each service like EC2, S3, IAMs. It will define a configuration rules for compliance checks and it can trigger the remediation actions. These all are features are there. Fine. Fifth services are there. AWS Trusted Advisor. What it does, Trusted Advisor, it means it is basically used for optimization and best practice. Like Trusted Advisor analyzes your AWS environment and gives recommendation for your cost optimization. These keywords you have to keep in your mind. It means whenever they are talking about recommendation for cost optimization, performance, or security fault tolerance, we have to use this trusted advisors. Advisor is there, na? They are giving recommendations. Fine. That keywords that you have to keep in your mind. Otherwise, you may forget like lot of services are there from AWS. Fine. And you make like everything will messed up in your mind. So these keywords you have to keep in your mind and it will be good for your like uh, things to get remembered. Some features are there with the AWS Trusted Advisor, which consists of cost optimization, performance, security, fault tolerance. Examples are there like Trusted Advisor finds, let us suppose it basically finds unused EBS volumes or idle EC2 instance and suggested deleting them. Fine. So with the help of this, and it may also warn that S3 bucket is publicly accessible, violating security practices. Fine. So that's how this trusted advisor is being used here. The next services is their AWS organization. AWS organization, it means it is used for multi-account governance. It means AWS organizations enable central management of multiple AWS accounts. It helps apply consistent policies, permissions, and billing controls across your organization's AWS account, essential for governance and compliance. Fine. Examples are there like let us suppose if you minus 5 AWS account like for dev, test, and prod. So with AWS organizations, you group them under one management account. Fine. And have to apply and you can simply apply a SCP, fine, to prevent users from disabling cloud trails or creating public S3 bucket. It means it's just a centralized management of all those services, all those accounts. Fine. Like if you want to explicitly disable the cloud, like from disabling cloud trails, or like if you want to anyone to create a S3 public S3 bucket in public with public access, you can configure it with the help of SCP. Fine. And SCP is basically a part of AWS organizations only. These things also you have to keep in your mind. SCP is nothing just a service control policy. It means whenever you have to enforce a policies on a setup account, you have to use this. And its SCP is only be used in case of organizations only. These things also you have to keep in your mind. Fine. So, so this is all about the the auto scaling, this is very important. Auto scaling, it means AWS auto scaling basically automatically extend the compute capacity to maintain the performance. Fine. Like whenever it basically ensured that the application has the right amount of resources at the right times based on demand. It means whenever the demand on the application increases, the auto scaling is going to increase the number of EC2 instance. If the spikes or if the spikes on the applications decrease, it's going to decrease the number of EC2 instance. It means it is basically going to auto scale the resources here. That's why it's basically very important. You just not manually have to add the number of EC2 instance. Fine. And it can be frequently used in the e-commerce application like Flipkart or something like during the big billion days or any other like during the festive seasons. Fine. If the loads or if the number of traffic increases on a particular server, what it does, it going to basically increase the number of EC2 instance at that time so that users won't face any downtime. Fine. And if the after festive season, if the number of traffic decreases, it automatically going to scale out the those resources. Fine. So that's how it's working here. What are the key features are there with the AWS auto scaling? So auto scaling, like it automatically scale in a scale out EC2 instance, EC2 task or DynamoDB capacity or Aurora replica. Fine. It support a target tracking, a step scaling and schedule scaling are there. These are basically the policies are there in scaling. Fine. Step scaling and schedule scaling. You can go through this scaling in deeper. I will try to cover each and every services in deeper as well. But this just a recap of all those services. That's why I'm going to thoroughly explaining each and everything here. Fine. And it can be integrated through tightly with the AWS Cloud. CloudWatch is very important. I have already told you that it can be integrated with all those AWS services. Fine. You can find it's very useful. Examples are also there with the AWS auto scaling. Like let us suppose if your e-commerce website experiences high traffic during a sales, CloudWatch basically monitor the CPU license, and auto scaling basically increases the EC2 instances from let us suppose if previously two are there, it will increase it to six when the CPU utilization exceeds 70%. Fine. And after traffic, whenever traffic drops, it basically try to scale back to two instances. And with the help of this, we can save the cost. That's why from the cost optimization point of view, this is very important. Fine. Okay. The next one is AWS Systems Manager. Fine. Systems Manager, it means they are talking about the central operation hub. It means it is used to manage, automate, and secure AWS resources at a scale. It reduces the need to manual SSH and manual access like SSH and improve operation visibility. Systems Manager there, which is very important. Like so many features are there with the system manager. Like if you have to execute some command across multiple EC2 instances at once, you can also use this systems manager. If you have to secure, like in session manager also it's being used, like if you have to secure and browser by access to EC2 instance without SSH, you can use systems manager. If you want automate operating systems or software patching, in that case also you can use systems manager. Fine. So a lot of features are there. It can be used in multiple cases there. Systems manager. Fine. But most importantly, it can be used to execute the multiple command across the multiple EC2 instance at once. Fine. Examples are there like if you need to patch 100 EC2 instance, you just use patch manager to apply patches. Patches, it means upgrades. Fine. So you just patch manager to apply patches during the maintenance window. Compliance report shows which EC2, like which instances are patched and non-compliant. No SSH key or bastion key required, say. Fine. So from the management and governance services, these all are the list here. For CloudWatch, we are using for monitoring here. CloudFormation, it's a infrastructure as a code which is used for governance. CloudTrail, it means auditing tools is there. Config, they are talking about the configurations. It means just check the resources and check whether they are compliant or not. Fine. Trusted advisor, it means they are talking about like they will give us the recommendations, best practices. Fine. They will check the like idle EC2 instance or unused EVS volume. Fine. Organizations, it means they are talking about the multi-account management. Auto scaling, it means it just scale the number of resources based on the demands. Systems manager, it means they have been used for operations and automation here. Fine. It just manages, patch, and automate the resources here. That's why it's been mentioned here, like patch EC2, run commands, and avoid SSH access. Fine. So these are basically the AWS management and governance services are there. One more services are there. I will try to cover these as well, but so many services are there. I won't be able to explain so much things are there because I have thoroughly like in detail I've documented everything. AWS Cloud Tower is there, which is used for landing and governance automation. You can go through this as well. AWS Cloud Towers is a managed governance services that help you set up, secure, and govern multi-account environment using AWS best practices. Fine. In simple way, you can it creates a ready-to-use, well-governed AWS landing zones for multiple accounts. Fine. Then after AWS Health Dashboard is there, which is used for service health and notification. Like then after license manager is there, which is used for software license management. And one more like management console, I think you are quite familiar with this. Like it's a web-based interface like this. It's a web-based interface. Yeah, this one. Fine. I don't know why internet connectivity is very slow here. I'm using Wi-Fi even though the connectivity is very low. Okay, no worries. Then AWS Service Catalog is there, which is used for externalized resource provisioning. Fine. Service quota is there, which is used for resource limit management. Just go through AWS. This is very important, like AWS Work Architect Framework. Total six pillars are there. Fine. Five pillars are there basically. Operational excellence, security, reliability, performance efficiency, and cost optimization. You can go through each and every one out here. Then after compute optimizer is there, which is used for resource right sizing, like if your EC2 instance and 10% of CPU uses, computer optimizers suggest a smaller EC2 instance. Fine. That's why it's been used for resource right sizing, which resources we have to use optimally here. So these are basically the services are there. Fine. So you can go through his management and governance services. Whatever the important services is there, I will try to cover it in first slide. Fine. So this portion has completed here. Security, INT, and compliance services has been completed. Management and governance services have been completed. These two has been completed. Now we will have to move to this billing and cost management services. Okay. Let me have to go to my billing and cost management services. Okay. So AWS billing and cost management services basically help you to track, manage, and optimize costs associated with your AWS resources. Fine. These services basically provides insight, alerts, and reporting tools to help organizations control spendings and optimal usage. Like whenever we have to check our AWS spendings, or if you want to visualize like which services has used the most, fine. If you want to diversify the cost based on the services, we are basically using these services here. Fine. The first services is there, AWS Cost Explorer. Fine. So AWS Cost Explorer is a tool to visualize, analyze, and forecast your AWS cost and uses. It can view data by services, linked account, tags, and more. It means whenever if you there is a centralized like there is a centralized uh, dashboard is there through which you can visualize this AWS Cost Explorer. It means we can sort the data, we can sort according to the tags here, according to the services here. These options are there at that fine. And it basically help to identify trends and detect unusual spendings. Fine. What are the key features for of AWS Cost Explorer? So it's an interactive chart to view daily, monthly, and custom time periods. So it has all three options are there. Either you can see the daily charts, with other you or you can see the monthly chart, or you can put the custom templates as well from this to this. Fine. It has a unified interfaces here. You can filter by services, regions, linked account, or tag. These three searching options are there. It can forecast the cost based on the historical data. It means based on the historical data, it can predict like how much cost you are going to spend. Fine. That's why for forecasting also this services is used. Questions has been asked in this manner, like which services is used in the cost forecasting. This cost explorer services is there. Fine. Identify underutilized resources as well. Examples are mentioned here, like a company want to check how much they are spending on EC2 and S3 over last 3 months. Fine. So using AWS Cost Explorer, they can generate a chart showing daily cost uses for S3 versus EC2, helping them to decide decide EC2 instance to reduce the cost. Fine. So that's how you can use this Cost Explorer here. Next service is there AWS Budget. Fine. What it is? So AWS Budget is basically used to set a custom cost or users budget and receive alerts when you approach or exceeds them. It means, let us suppose if you want to create a budget live, if the total cost will exceeds $5, we can get a notification. Fine. So with the help of this, you can set a budget. What are the key features are there with the AWS budget? Budget that's like cost, uses, and reserve instances saving plans are there. Alerts via emails, SNS, these options are there. It means whenever the trace value has been exceeds, it's going to send alerts via SNS. Fine. Examples are there, like let us suppose an organization sets a monthly budget of $1,000 for development EC2 uses. If the cost exceeds $800, an email is triggered to them to prevent overspending. Fine. It means they want to spend this, but if they have made a budget, like if the cost exceeds 800, they are going to receive the emails. So that's how you can prevent those overspending with the AWS budget services here. Fine. Third services are there, which is AWS pricing calculator. Fine. What is this AWS pricing calculator? So it basically be used to estimate the monthly cost of AWS services before deployment. It means whenever we have to calculate the monthly cost before the deployment, like before the deployment, if you just have to thoroughly calculate the what are the total costs associated with the AWS services, then we can simply use AWS calculator, pricing calculator. Fine. That's why it basically allow you to plan, budget, and optimize architecture based on costs. It basically calculates the cost from multiple services together. There is a customized configurations are there, like instance type, storage size, data transfer. It can generate a detailed PDF and Excel report. Fine. Examples are there, like a startup company plan to deploy web applications on EC2, RDS, and S3. Fine. So using this AWS pricing calculator, they can estimate the issue, like they will estimate like on EC2 instance, they have to spend $150 per month, RDS $200 per month, S3 $50 per month. So the total estimated cost is around $400. Fine. So with the help of this, they can simply plan their budgets. Fine. Okay. Fourth services is their AWS cost and usage reports, which is simply be considered as CUR as well. Fine. So AWS cost and usage reports basically provides a detailed CSV or Parquet files containing a cost and user information. You have to keep in mind like detailed CSV or Parquet file. Fine. So it basically provides a detailed CSV and Parquet file. Parquet is basically a type of file is there. So detailed CSV or Parquet file which consists of cost and use. This is very important. Fine. These things you have to keep in mind. So these files are basically highly granular and suitable for analytics and integration with BI tools. It means roughly it's basically we use in data science, like whenever we have to do analytics operations, like some other services are there, like Redshifts or something are there. In that case, we need some complete like CSV files are there, which consist of all those detailed information regarding. Fine. That's why this is used for that report making. Fine. What are the features are there? So breakdown, you can break down the cost by services account and regions and tag. It basically store the report in S3s for historical analysis. It basically integrate with Amazon Athena, QuickSight, or Redshift for deep analysis. These things are there. Examples are there like let us suppose if the large enterprise exports CUR data to S3, then uses Athena to analyze EC2 uses by a department, helping identify team consuming the most resource. Athena is there. Athena is basically AWS services which is used like whenever it basically used to do SQL operations on basically whatever the data has been extracted from either Redshift or S3s. Fine. Then after AWS cost anomaly detection services also there, it is basically used to detect, it basically uses a machine learning and which is used to just monitor the AWS spending continuously and automatically detect unusual and unexpected aspect. So whenever whatever the services are there from AWS, if they are using machine learning, fine, they are basically going to use it in real time basis, fine. Features like automatically detect anomalies using ML models. It can create anomalies, monitors at account service and linked account level. It can set alarms threshold and receive notification via SNS or emails. It can help identify the issues like misconfigured resources or runaways workload. Fine. So in that case, like examples are mentioned here, like DevOps teams notices a sudden spike in AWS cost. Fine. Cost anomaly detection alerts them that Lambda and DynamoDB costs increase abnormally overnight, helping them quickly identify a faulty deployment and stop unusual spending. It means whenever they are saying like there is a sudden spike in cost, from this cost anomaly and detections alerts, they would be know that oh Lambda and DynamoDB costs abruptly increase at night. Fine. So help with the help of this, you can simply know like what went wrong, like which services can be configured, like which need to be configured, fine, correctly. So with the help of this, you can use those services here. So this is basically the summary of all those services are there, like Cost Explorer, Budgets, Pricing Calculator, CUR, and Cost and Memory Detections. Fine. So these all are from the billing and cost management services. Then after this part has been completed, fine. Now we have to move on to the container and Kubernetes services. These are basically the, especially from the DevOps tool. One second. Okay, no worries. Container and Kubernetes services. AWS basically provides a set of container services to build, deploy, and manage I think you are quite familiar with the use container. Containerization of application. It means whenever we have to pack those all application code with their dependencies, we are basically consider it as a containerized application. Fine, so that it can run smoothly irrespective of the environment. Fine. And these services basically integrate with the serverless compute like Fargate and provide orchestration. So basically, three services are there. The first one is ECS, second one is EKS, and third one is Fargate. Fine. So in serverless architecture, in place of EC2 instance, we are using Fargate here. Fine. Fargate is just a compute service, just like EC2 instance, but it's a serverless. Fine. In case of EC2 instance, we have to manually configure each and everything. Fine. But here, Fargate is basically a serverless. Okay. And okay, I will try to explain each and firstly, I will going to create this ECR. What is ECR? ECR is basically Elastic Container Registry. Fine. It means it is basically, I think you are quite familiar with Docker over here now. Docker has a Docker hub. Fine. It means where you can store your container images, fine, images. Just like same AWS has ECR, Elastic Container Registry, fine. That's why Amazon ECR is a fully managed Docker container registry for storing, managing, and deploying their container images. One second. What are the key features of this ECR? It has both it has both features like you can create a private repository as well and you can create a public as well. Private and secure container repository, it can integrate seamlessly with the ECS, EKS, and Fargate, and it is basically used for some image scanning and life cycle policies. These are the features of this one. Like whenever developer used to push their Docker images of a web application to ECR, ECS basically pulls the latest image from ECR and deploy it to and just deploy it to EKS or any other. Fine. So that's how this ECR is there, which is nothing just a container registry. Registry, it means it's just a repo. Fine. Okay. First one is ECS is there. ECS, it means it's a container services. AWS ECS, Amazon ECS is basically a fully managed container orchestration services that lets you run Docker containers on a cluster of EC2 instance with or with a Fargate. It means whenever we have to orchestrate the containers, we can use either ECS or EKS. ECS is just like AWS own container orchestration services. But if you want more complexity, like if you want to integrate Kubernetes, we have to use EKS. But if you don't want to go much complexity or we don't want so much complexity of Kubernetes, we can use ECS as well because ECS is basically for low applications. Like whenever we have to deal with the low applications, it has a simple configurations and we can go with ECS. Fine. That's why ECS is basically entitled to AWS only. But EKS, like it's a basically Kubernetes based services is there. Fine. In case of ECS, it basically support a EC2 launch time, like you manage the instance, or you can use serverless Fargate. You have both options. Either you use launch type as EC2 instance, or you can use launch type as Fargate. If you are going to use launch type as Fargate, it means it is the case of serverless. If you are choosing launch type as EC2 instance, it means you literally have to manage everything inside those servers. Fine. And one more thing is there, this ECS can be integrated seamlessly with the other AWS services like IAMs, CloudWatch, and ALBs. Fine. And it has some features like task definitions are there. And I think if you have gone through the Kubernetes console, there is some pod.yaml is there. Fine. Their deployments are there. Just like same in ECS, task definitions are there. Fine. Examples I mentioned like let us suppose if a startup deploys a microservices application using ECS, each microservices runs a Docker container. ECS basically manages the deployment, scaling, and health check, and it can be monitored using the CloudWatch. Fine. Second one is there EKS. EKS is Elastic Kubernetes Service. It means Amazon EKS is basically a fully managed Kubernetes services that basically simplify running Kubernetes clusters on AWS without managing control plane. It means in case of this EKS, we just not have to worry about the control plane management. AWS is going to take care of this part. We have to worry or we have to manage the worker node only, worker plane only. Fine. This is basically the advantage of using AWS. But if you are using Kubernetes, you have to manage both control plane as well as the worker plane. Fine. It basically works on the this Kubernetes is basically work on the master slave architecture. Master, it means they are talking about the control plane. Slave, it means they are talking about the worker plane. Fine. And that basically pod is going to basically run on those worker plane. Fine. Master node, some tools are there like API schedulers are there. Then after some API servers are there, these tools are there. Fine. What are the key features of EKS? It basically runs a standard Kubernetes workload. It can be integrated seamlessly with other AWS services. These are fine. It basically support auto scaling, managed node management, and Fargate. These are things are there. Examples I mentioned, like if your applications are the multi-service application on EKS, Kubernetes basically manage the pods of each microservices. Autoscaler basically scales basically the pods based on the CPU usage, and Fargate Launcher basically remove the need to manage the workloads. Fine, these things are there. Fargate I have already mentioned, like Fargate can be used with both ECS as well as EKS. Fargate is a serverless compute services engines for containers, allowing you to run containers without managing servers or clusters. Fine, and it can work finally with both ECS and EKS. Automatically provision and scaling options are there, which basically reduces the operational head. Fine. Examples I mentioned, like let us suppose if the company deploy containerized Node.js application using ECS with Fargate, developer only have to define the task. Developer only define tasks like CPU and memory. Fargate runs container without managing EC2 instance and auto scale it based on the demands. And with the help of this, we can increase the we can enforce the cost optimization. Fine. A complete architecture I mentioned like there in which we are using this ECS ECR and Fargate. Like developer firstly build the Docker image locally, fine. Then they push the image to ECR for version the storage. Then after create a ECS task definition for specifying like which container image we are going to use and what are the services. After that, they just deploy ECS services using Fargate, which runs container serverlessly. And after at last, we are basically integrating with the CloudWatch for their monitoring and auto scaling if needed. Otherwise, we can avoid this part as well. In the same manner, we can use it with EKS as well. Fine. So these things are there. You can go through. These are basically comes under the container and Kubernetes services, ECS, EKS, ECR, and Fargate. Fine. So I have covered this portion as well. Developer tools. Okay. Where is developer tool? This is there. Developer tool, it means AWS developer tool basically provide us services for DevOps automations like CI/CD monitoring. Fine. The first services are there, AWS Cloud9. It's a cloud-based ID. Fine. It means integrated development environment. So cloud, just like a just like a you may simply say Visual Code or something, whatever we are using locally. So Cloud9 is an online IDE. It means integrated development environment where you can write, run, and debug code directly in your browser. No local setup. Fine. In the same word, I think we are in the same manner like whenever we are using VS Code, we can write the code, we can run, and we can debug the code from locally. In the same manner, AWS has the services Cloud9, which is nothing but a cloud-based integrated development environment. Fine, and it can basically support multiple languages like Python, Java, Node.js, C++, etc. Fine. And it has a pre-configured terminal with AWS CLI. Fine. Examples I mentioned like let us suppose if the developer create a Python web applications in AWS Cloud and write the code, he just have to write the code, he have to test API using the built-in terminal, pushes changes to the code commit directly. Code commit is just like a GitHub. Fine. It's just a GitHub repository. This Cloud9 is just like a Visual Code. Fine. VS Code, whatever we are using. Code commit is just like a GitHub. Fine. It's a AWS own source code repository. Fine. So AWS Code Commit is basically a fully managed Git-based repository there, which is used for hosting the source code privately. Fine. It has also both features like private as well as public. It is similar to GitHub or Bitbucket, but fully hosted on AWS. It means you can simply say it's AWS GitHub repo. It's just AWS GitHub services. Fine. It means just like same, you can store your code on AWS. Fine. And it can be integrated with other services as well, like for IAMs for fine-grained access control. Fine. In the same manner, whatever you are using, like whenever you have to store the application code in code commit, you just do git clone, then have to put the URL here. This is basically the URL in case of code commit. HTTPS git github code commit dot, then after the reason name here there, amazon.com is there, then a version is there, or then further like application name is there. This is basically the stack. The first is Cloud9 is there, then after code commit is there, then after comes a code build, then code pipeline. These all are basically the developer to code deploy. Fine. Code build, it means it is used for build and test automation. It means code build basically compiles your code, run the test cases, and just produce a deployable artifact like they will create a .jar file, .zip file, or Docker images. Fine. It just is used to test like whatever the test like unit test or some other test on our code, and it will just create a deployable artifact either in the form of jar or in the form of zip, or it may be the docker image as well. That's why it's a fully managed build service. Fully managed build service, it means no build server needed, and it can be integrated seamlessly with other services like code commit, S3, and code pipeline that we will study later. Fine. And in this case, we have to pay for only for what build times we have been used. Examples are mentioned like whenever a developer commits the code to code commit, code pipeline is basically just like a Jenkins. Fine. So code pipeline basically triggers the code build. Code build basically uses this file to run the code. Fine. And it will create a artifact with the extension .jar. Fine. And the output jar file is stored in S3 for deployment. Fine. Code pipeline, it means it's a CI/CD orchestration services. Fine. It means just like I've already told, it's just like a Jenkins. Code pipeline basically automates the entire CI/CD process from code to build, from code to build to deploy. Fine. And it can be integrated with other services like code commit, code build, code deploy, CloudFormation, and any other third-party services as well. And it's a fully managed here. And like this is basically the workflow like source, code, deploy. For source, we are using code commit to detect a commit. For build, we are using code build here. For deploy, we are using code deploy that we will study later. And this, so for CI/CD, like if you are aware about the complete CI/CD pipeline, so for in place of Jenkins, we are using AWS has their own services code pipeline, just like same. So whenever the developer is trying to commit the code to code commit, the code pipeline is basically trying to trigger the build. That build basically trying to run the unit test on the codes, and it basically trying to create a artifact with the extension .jar or .zip, .zip, and it's basically trying to store it in S3. Fine. Then after we will try to deploy it to the code deploy. Fine. AWS Code Deploy is basically a automated deployment services, and here it's mentioned like code deploy automates application deployment to EC2, ECS, Lambda, or any other premises on-premises server. It means we can deploy the our application to any like any destinations like be it EC2 instance, ECS, Lambda, or any on-premises servers as well. And one more thing is there, like with the AWS Code Deploy, it basically support blue-green deployment, rolling deployment as well. I think so many deployment tabs are there, like rolling deployment tabs are there, blue-greens are there, canary are there, so many are there. It can support all, fine. And there is a feature like automated rollback also features are there on this code deploy. Fine. So you can go through is these are Fine. And like if you're putting together, like if you're using all those services together, it's a complete workflow. Like developer used to write the code in Cloud9, fine. It then after they just push it the code to code commit. Code pipeline basically trigger for build, and it basically trigger a code build, and code will basically compile the code and test the application, and it basically deploy those application to EC2 instance, and pipeline complete automatically, no manual setup. These all are basically like whenever we are using these all services collectively, this is basically the workflow look like. So this is all about the developer tool here. So I have tried to cover this portion as well. Now I have to move to this application integration services. Fine. Okay, one second. Yeah, so this is AWS application integration services. So AWS application integration services basically is used to connect and coordinate with the different applications, services, or microservices efficiently. That we can coordinate, like we can connect multiple applications together. Fine. The first services is their AWS SES, which is nothing just a simple email services. Fine. So Amazon SES is basically a cloud-based email sending services which is used for sending transactional mails, marketing messages, or email notifications securely and reliably. It means whenever we have to send a particular mail to a number of users or number of emails addresses, we can use simple email services. Fine. Key features are there like which is used to send, receive, and track emails at a scale. It supports multiple sending methods like SMTP, AWS SDKs, and APIs. It built-in reputation management and analytics, and it can be integrated with the other AWS services as well like SNS, Lambdas, and S3. Fine. Like we can create with a Lambda like whenever any uh, file or whenever any object has been uploaded to some particular bucket, then it's going to basically invoke some Lambda function, and after that we will supposed to receive an email services like that you can configure. Examples are mentioned like an e-commerce website uses SES to send the order confirmations email to customer, promotional newsletters to the subscriber, and delivery status update integration with S3s and SNS for the alerts. Fine. So in this manner we can use this SES here. The second services is the Amazon SQS. SQS is nothing but a fully managed message queuing services. It basically enables decoupling and scaling of microservices, distributed systems, and serverless. It means this services is very important. This SQS is basically used for decoupling of the microservices. Fine. Like whenever we are placing an order, the first order goes to the SQS queue, and if the like multiple worker EC2 instance are there or some lambda functions are there, that basically is going to asynchronously fetch those order processing, and they used to perform those actions. Fine. That's why SQS is very important services from this AWS. One concept is there like it can support already mentioned like it is used for decoupling of the component, and it can support both like standard queues as well as first in first out queues. A standard it means at least one delivery. It means whenever order has been placed, the receiver is basically trying to like all those messages whichever be in queue is going to be delivered at least once. It means there might be possibility that it can be delivered multiple times. But in case of first in first out, it's going to be processed exactly once here. Fine. That's why it support both standard queues as well as first in first out queues. Fine. And it automatically can scale a large number of workload there. Fine. Examples are also mentioned here, like in an e-commerce platform, like whenever customer is places an order, it basically added to the SQS queue, and multiple workers EC2 instance or the Lambda function basically trying to process those orders asynchronously. It means whenever they want, they just take those messages. It means like in the same manner, like when I think we are quite familiar, like whenever we are placing some order or something on a Flipkart or any other e-commerce platforms, I think after a couple of minutes later we are going to receive those notifications. You have, I think, noticed it because those servers are basically be integrated with SQS. Like whenever we are placing the order, firstly it will goes to the SQS queue, and after that, whatever the target services are there, be it EC2 instance or any other Lambda function, it's basically trying to take those messages asynchronously. Asynchronously, it means it's not continuous process. Fine, they have to take one by one like this. So that's all about this SQS. Then after next services is there SNS. SNS it means simple notification services. Fine. And it basically be works on the pub and sub messaging services. Publish and subscribe. Fine. So this is basically where it is. Yeah. One second. This Amazon SNS is basically a fully managed version of messaging services and delivers message to multiple subscribers. Fine. Key features are there like it is used to publish the message to emails, SMS, Lambdas, HTTP or SQS. It basically works on fan out architecture for broadcasting message. It means fan out, it means they just broadcast the message. Whoever be the subscriber, they just want to take it. If they are not subscriber, like whatever, like if five subscriber are there, only those five subscriber are being able to get those messages. They just broadcast the messages. Fine. That's why some things are there that you have to keep in mind. Firstly, it's basically be a pub and sub messaging service. Pub it stand for publish, sub stand for subscribe. Publish and subscribe messaging service. Second one that you have to keep in mind, it's basically work on fan out architecture. It means it just broadcast the messages. Fine. And it can be used seamlessly with the other services like CloudWatch, Lambda and in event bridge. Examples are mentioned like whenever a new product is added to the catalog, SNS basically send a email notification to marketing teams. It can trigger a Lambda function to update the search indexes, and SQS basically message for downstream services. Fine. SQS it means they are talking about the decoupling. There is one more services there, Amazon Event Bridge. Fine. What is Amazon Event Bridge? So Amazon Event Bridge is a serverless event bus services that help different AWS services and applications communicate with each other using evented. Fine. In simple word, like whenever something happens, an event is triggered, and event will basically route it to the right services automatically. Examples like whenever like a payment system send a event to event bridge, like whenever payment succeeded, Lambda triggers order fulfillment. Fine. Then after SNS basically sends the confirmation mail, and then after one more service is the stay function, which is used to update the inventory according to the systems. Fine. So that's how this event bridge is working. They just want to communicate with the other services or application which either are using the event. Like whenever this event occur, they will try to invoke the other services as well. Like that, it's basically working. That's why in key features you can say ingest event from AWS customs or SaaS application. Fine. It means event can be anything, be it from AWS, be it custom, or be it from any other SaaS application. It can applying filtering. We can apply the filtering rules and route to multiple targets. And there is a build like a real time and event. It basically we work on the event-driven architecture. It means whenever some events has occurred, it has to get invoked without pooling. Fine. So this is all about the event bridge. One more services is there, which is AWS step function. Fine. What is a step function? So a step function is basically a serverless orchestration services that basically coordinate multiple AWS services into sequential, parallel, and coordinated workflow. So whenever we have to work with the workflows here, serverless orchestration services, we are basically using AWS step functions here. Like In other definition, it can be mentioned at AWS step functions is a serverless orchestration services that visually coordinate multiple EC2 services like Lambdas, SNS, DynamoDB with reliable, scalable, and multi-step workflows, making it easier to build complex applications by defining steps, managing state, handling errors with automated retries, making decisions all through a visualized editors, or in it can be written in JSON format. Fine. That's why in like if you are talking about the examples, you can take examples like an order processing workflow might like whenever an order has been processed, the workflow would be like in the simple way you can simply say like lambda, like whenever we are creating a lambda, we are basically trying to define a particular set of actions using a lambda. Fine. Like whenever we have to validate the order, we have to create a lambda. Whenever we have to charge the customers, we have to create a lambda function. Whenever we have to update the inventory, we have to create a separate lambda function. Fine. But whenever we want to integrate all those lambda functions, then we can use step workflow. Step workflow, it means they just you can simply say integrate all those lambda function in a proper manner. Fine. That's why it's mentioned like whenever order processing happens, firstly it will invoke the first lambda, which is used for validating the order. Then after it will invoke the second lambda, which is used to charge the customer. Then after they will invoke the third lambda, which is used to invoke the inventory. And at last they will notify the shipping team with SNS services. Fine. That's why this AWS step function orchestrates all these steps with automatic retries and monitoring. Like in these, if some steps has failed, they will try to retry it again. Fine. That's why it's a useful services step function. So whenever there's a term like orchestration, especially for the workflows, we are using this step functions here. Fine. Other services is there, which is AWS SWF. SWF is nothing but a simple workflow services. So it's a fully managed workflow services used for coordinating humans and automated tasks across distributed systems. So it basically support the human interaction in the workflow. It basically track the workflow states and tasks while like whenever we have to deal with the long running processes now, we are basically using this SWF here. In example, you can simply say in a loan approval systems like SWS coordinate tasks such as document verification, credit scoring, final approvals like this. Some tasks are performed by humans, others by Lambda functions. SWF ensures every step completes and tracks all our workflow. So this is fine, but these are not so important services, but you can go through it this as well. So I have tried to cover all those services, whatever possible. Out of this, simple notification services and SQS is very important. After that, event page is also fine. Step functions we are also using. Fine. So in a nutshell, we can simply say these all our services are there. SES, SQS, SNS, Event Bridge, Step Function, and SWS. Fine. SES, it means it is used to send transactional and marketing emails. SQS, it means it is used for message queuing, which is used for decoupling of the macro services. Fine. SNS, it means it basically works on fan-out architectures. It means pub and sub notification systems. Fine. It just used to broadcast the messages. Event bridge, it means it works on event-driven architectures. Fine. Step function, it just orchestrates the workflow. SWF, it just manages the long-running or human workflow. I've already told you whenever there's a long-running job processes, we are basically using SWF here. Fine. So these all are the application integration services are there. Fine. So I have tried to cover this portion as well. Now the last portion is migration. Fine. Migration services. One second. Yeah, AWS migration services. So what is AWS migration services? AWS migration services, it means whenever we have to move the applications data or workload from on-premises environment, data centers or other cloud providers or other clouds to AWS, we have to use migration services here. It is used to securely move the workload to AWS with minimal downtime. Fine. Desktop from the AWS best practices. AWS provides a tool and framework and best practices to simplify the assessment, migration, and modernize processes. Some key services are there, like from some key AWS services are there, which is used for migration. Fine. The first one is their AWS Migration Hub. So it is basically used for centralized tracking services for migration processes across multiple AWS and partner suite. It's a unified dashboard to track the application migration. Fine. So Migration Hub is basically is a dashboard which is used to track the application, like whatever the applications we are migrating from on-premises to AWS. It basically gives you a unified output like everything regarding that migration. Fine. Second service is the AWS Application Migration Services, which is also known as MGN. Fine. So it is used to automate the lift and shift migrations by replicating servers to AWS. Like whenever we have to move on-premises servers like Windows or Linux to EC2, easily we can use application migration. It means what we are doing, we are basically trying to move the applications from on-premises to EC2 instance. Fine. That's why here use here lift and shift. Fine. Then after other services is there AWS database migration service there. It means whenever we have to migrate the database to AWS securely and quickly with minimal downtime, so we can use this database migration services. Fine. Let us suppose if you have to migrate the Oracle to Amazon or MySQL to RDS, we can use this Amazon migration services. Fine. Then after one more service is there, AWS Server Migration Services. It means it's a agentless services to migrate virtual machines like VMware or Hyper-V to AWS. Like whenever we have to migrate the large scale VM from a data centers, we can use this server migration services. From the name, you can like things are get clear. Like here, application migrations are there. It means whenever we have to migrate the application, whenever we have to migrate the data, that we are using DMS. Fine. Whenever we have to migrate the servers, we are using SMS here. Fine. In the same manner, there is services like AWS Snow family. The Snow family basically consists of these three services: Snow Cone, Snowball, and Snowmobile. So these are basically used to these are basically the physical device which is used for large scale data transfer whenever the network bandwidth is very low. It means those areas where network connectivity is very slow or low. In that case, there is a need to physically transfer the data to AWS. Fine. In that case, we are using Snow family here, like transfer data, transfer terabytes or petabytes of data to AWS. Fine. Then after other services are there, AWS Data Sync. For what purpose we are using this data sync here? So it is basically be used to automate the online data transfer between the on-premises storage to AWS like S3 or EFS. It means whenever there is a need to have online data transfer, fine, from on-premises storage to AWS, especially in case of S3 or EFS, we are using this data sync services here. Fine. It's a continuous or scheduled data synchronization. Fine. Cloud Endure migration services there, which is used to provide the disaster recovery and migration solutions with real-time replication. It's a fast, reliable workload migration with minimal downtime. Then after AWS application discovery services is there, which is used to discover the on-premises servers, application or dependencies to help your migrations. And it is basically like it basically work on like during the assessment phase to create the migration plan to dependency. It means it basically be used like during the assessment phases. Fine. The last one is the AWS Transfer Family. So it's a fully managed service for securely transferring file like FTPS, FTP directly into the Amazon S3 or EFS. And it is used like it is used in the case like replace legacy file servers or on-premises FFTP servers. So these are all basically the AWS migration services, out of which few services are very important like migrations hub, application migration services, database migration services, server migration, Snow family, and this application discovery services. Fine. So whenever we are migrating some applications or services from on-premises to AWS, some like we have to come across with a different phases. Fine. That's why there is some key phases are there in cloud migration. Five stages are there, like five, you can simply say stages are there. Firstly, we are preparing, then planning, then we are migrating those workload, then we are monitoring it, then we are operating it. Fine. So I will try to explain each and every five steps here. In the preparation, we have to access the existing IT environment and define the clear migration goals in a scope, like for what purpose we are using to migrate. Fine. It consists of the evaluate current infrastructures, identify dependency, and set a migration objective. Fine. At what set of workload we are supposed to migrate it to AWS. Fine. That it basically comes under the preparation. Then after planning steps has came. In planning, we are basically creating a detailed migration roadmap and choose the right cloud tools, services, and architectures. So select from the 7 AR that I will discuss here. Fine. We are going to select the AWS migration strategy. It means which strategy we are going to adopt. Fine. We have to choose the services, like which services we are going to use, which services we are going to migrate, and it will define the timelines and role as well. So it all comes under the planning phases. Fine. Then after the next phase is migrate. It means in this phase we have to move those applications or workload or data securely to the clouds using automation tool. It basically consists of like use either we have to use any of the services which has been explained earlier, like MGN, DMS, or Snowball, and have to test those migration workloads as well. So this is basically a migration phase. Fine. Then once the migration is done, we have to continuously track the application's performance, cost, and compliance. Fine. And for continuous monitoring, we are basically using this CloudWatch, CloudTrail, and AWS Configure. Fine. That's why it's been used for cost optimizations or revenue uses. And at last we have to monitor it. Like we have to manage and optimize the workload for long-term success with automation, scaling, and reliability performance. For this, we are basically using the auto scaling, AWS backup, or these other services. Fine. So these five are basically the phases of cloud migration: preparation, planning, migrate, monitor, and operate. Fine. Then after 7 hours of like what 7 strategies are there, like what strategy we are going to follow while we have to move those applications from on-premises to AWS. So first is rehost, then replatform, then refactor, repurchase, reallocate, retire, and retain. Fine. I will try to explain each and everyone. Like for first, like rehost, it means in case of rehost simply consider as lift and shift. Fine. Rehost, it means in case of rehost, we just have to move the application as it is to AWS with little or no changes. For example, like whenever we have to migrate VMs from on-premises to EC2 using AWS application migration services, we don't have to do anything. We just have to move the application as it is to AWS. Fine. With no modification, no changes. Fine. In case of replatform, which is lift, trunker, and shift, we have to do minor changes for better performance before moving. Like if you want to move the applications to EC2, but in place of RDS, but we want to use RDS in place of self-managed database. It means we have done a bit modification here. We have used RDS in place of self-managed database here. So if we have used a bit modification, we have to use re-platform here. Fine. Refactor, it means whenever we are redesigning the application to take full advantage of cloud native features, it comes basically under the refactor. Refactor or re-architect. Like whenever we want to move the monolithic application to microservices on AWS, Lambda or ECS, we can consider it under refactor or re-architect. It means what we are doing, we are completely going to architect those applications. Fine. Then next strategies are the repurchase. Repurchase, it means replace the existing application with a SaaS-based or cloud-native solution. Like whenever we have to replace the on-premises CRM, Salesforce or ServiceNow, it basically comes under the repurchase options here. Fine. Then reallocate is there. It means whenever we have to move entire servers or VM to AWS without changing their architectures, we are using this reallocate. Examples like whenever we have to migrate, one second, whenever we have to migrate the VM workload directly to VM clouds, we are using this reallocate here. Next one is retire. Retire, it means decommission or remove applications that are no longer needed or add no value. Like it can be used like whenever you have to turn off the legacy tools or duplicate systems. So whenever there comes decommissions criteria, it can be we are using this retire migration strategies. And last is retain, which is revisit or reevaluate as well. It keeps some workload on premises or hybrid due to compliance legacy and dependency resources like keep mainframe workload locally. It means whenever we have to keep some workload on premises or if you are working in hybrid, we can use this retain migration strategy. The total 7 migration strategy are there. You can based on your plannings, you can opt anyone. It totally depends upon you like what set of actions you need to perform. Fine. After that, these are some features, like these are some benefits of AWS migration. Like what are the benefits of AWS migration? Cost optimization. It means we have to pay as you go. It basically follows a pay as you go model, which eliminates the hardware cost. Scalability. It means automatically scale resources using the AWS scaling, auto scaling. Reliability is means high availability and multi-agent redundancy is there. Security is meant is built in compliance and this. Innovation are there. It means we have access to AML analytics. Agility it means faster and deployment. So with the proper migration strategy, we can improve the system's scalability, reliability, and cost optimization. So this basically concept all comes under the AWS migration services. Fine. I have to cover all. So that's all about the AWS in one shot. So I have tried to cover all those services from AWS core concept to migration. So this basically complete the whole AWS in one shot playlist. And like I have tried to cover all those services in the previous videos. I have covered compute, storage, networking, and databases. And in this video, I have tried to cover security, anti and compliance services, management and governance services, billing services, container services, developer application integration, and migration services all. So I have tried my best to cover all those services. Please go through this GitHub repo. I have really documented each and everything very beautifully inside it. And if you find any dot, please you do comment, and I will appreciate each and everyone effort here. And if you have a query, you can ask me over call as well. So yeah, that's it about this playlist. Please stay tuned with me. I will try to upload some Python related and DevOps related video as well on these tutorials. So yeah, that's it. Bye bye. Take care. Please do practice and please go through it. And please stay tuned. And if you haven't subscribed this channel, please subscribe it. Bye bye.